Okay, so let's take a look at another question from the topic of electromagnetism. This is quite an interesting question. We're asked, why do we not consider electric and magnetic forces when modeling orbital behavior of planets and satellites? Okay, so we can approach this in three ways. The first answer is we don't need to, right? We don't need to. And the reason we don't need to is if you are looking at something like astrophysical modeling, for example, you are looking at objects that are so far away, the level of precision that you have at best is terrible, right? So you have terrible precision for objects. We're talking from different galaxies, outer parts of the universe. We can barely understand anything about them anyway. So you don't really need to build incredibly complex models that factor in, electromagnetic forces or fields. You can just look at their basic movement and pretty much assume that it's gravitational. So this is the first thing. We really don't need to when you're looking at very, very distant objects. A second possible answer to this question, if we're thinking about satellites, we launch or local objects which are considered satellites, moons for example, they might not necessarily have any net charge, right? So the net charge might be 0 or close to 0. Close to 0. If the net charge on these objects is 0 or close to 0, the forces exerted through electric fields or magnetic fields are not really going to do anything, right? So there's not going to be a problem anyway. We have another possible answer to this question. And this part gets a little bit more complicated. Part 3 will be we sometimes do, right? We sometimes do. If you look at research papers in, say, stellar magnetospherics or something like that, when you're looking at the magnetic fields surrounding stars, if you think about the sun, Sol's magnetic field, there are a lot of people who do research in stellar magnetospherics, right? They're studying how do you model the fields created by these particular objects. The reason you would do that is if you're going to launch satellites around it, the satellites may actually get affected by that field, right? It may be the case that the magnetic fields or the electric fields, the electromagnetic fields in the case that they're both linked essentially, they may actually start affecting things when you send objects near to them. So some people do. Very, very few people at this point in time, right? There will probably be more in future. The other thing is, if we think about a fourth possible answer, so this will be IV, not VI, the force will be relatively less than the other forces. So it is possible that electric or magnetic forces are trivial. Trivial by comparison to other forces, right? If you have one force which is 10 billion times larger than another force, the small force doesn't really do anything, right? It's not completely overwhelmed, but it's almost completely overwhelmed by the larger force. So, we don't need to if we're looking at very distant objects. These forces or fields we can't really discern anyway. 2, net charge might be 0 or close to 0. If the net charge is 0 or close to 0, the fields don't really do anything. 3, sometimes we do advanced applications of studying, say, astrophysics, astronomy. If you are thinking about certain types of astronautics or aeronautics, there are some people who do study how fields affect, charges in particular machines, but it's incredibly complicated. And then 4, it may be the case that if there are electrical magnetic fields which are exerting forces on objects, that those forces are trivial compared to other forces, right? Say gravitational forces may completely overwhelm them. So this is an approximate answer to this question. This is a very interesting sort of essay style. You could write the answer as an essay. It's a sort of short answer, long answer kind of exam question. To get marks out of these questions, you need to state as many comments as you can and back them up as much as is possible. So I've backed my points up here with discussion about them. If you're in an exam, write why, right? Say we don't need to because if we're looking at distant objects, we have very poor precision anyway, or net charge might be 0 or close to 0. If net charge is close to 0, then the forces are close to 0. So back these up with additional wording, but this is an approximate answer to question as listed.